Imagine a world where your car drives you to work while you relax, check your phone, or even take a short nap. No steering wheel stress, no traffic frustration, and fewer accidents on the road. This is not science fiction anymore. It is the reality engineers are building right now. Self-driving cars are one of the most exciting breakthroughs in modern technology, powered by artificial intelligence, sensors, and massive data processing. In this video, we will break down exactly how these cars work, what makes them smart, and whether they are truly safe for everyday use in the future today. At the core of every self-driving car is artificial intelligence, often called AI. This is the brain of the vehicle, responsible for making decisions just like a human driver would. The AI system learns from millions of miles of driving data, including road conditions, traffic patterns, and unexpected situations. It does not just follow simple instructions, it constantly analyzes its environment and adapts in real time. This ability to learn and improve over time is what makes self-driving cars different from traditional automated systems that only follow fixed rules without understanding context. To understand how self-driving cars see the world, we need to talk about sensors. These vehicles use a combination of cameras, radar, and LiDAR technology. Cameras capture visual details like traffic lights, lane markings, and pedestrians. Radar helps detect objects and measure their speed, especially in bad weather. LiDAR uses laser pulses to create a detailed three-dimensional map of the surroundings. By combining data from all these sensors, the car builds a complete picture of the environment, allowing it to detect obstacles, predict movement, and navigate safely through complex roads and busy city traffic. Once the car collects all this data, it needs to process it instantly. This is where powerful onboard computers come into play. These systems analyze thousands of data points every second to understand what is happening around the vehicle. For example, the car must recognize whether an object is a pedestrian, a cyclist, or another vehicle. It must also predict what that object might do next. Will the pedestrian cross the road or wait? This prediction ability is critical because driving is not just about reacting. It is about anticipating actions before they happen to avoid danger. Self-driving cars are also guided by advanced mapping systems. These are not the same maps you use on your phone. They're highly detailed digital maps that include lane positions, road curvature, traffic signs, and even the height of curbs. These maps help the car understand exactly where it is and what to expect on the road ahead. Combined with GPS data, the vehicle can localize itself with extreme accuracy. This precision allows it to stay within lanes, take correct turns, and follow routes safely, even in areas where road markings are faded or unclear. Another important concept is levels of autonomy. Self-driving cars are categorized from level 0 to level 5. Level 0 means no automation, where the human does everything. Level 1 and 2 include features like cruise control and lane assist. Level 3 allows the car to handle most driving tasks, but still requires human attention. Level 4 vehicles can operate independently in specific conditions, such as certain cities or routes. Level 5 is full automation, where no human intervention is needed at all. Most cars today are still between Level 2 and Level 4 development stages. Safety is one of the biggest reasons companies are investing in self-driving technology. Human error is responsible for the majority of road accidents worldwide. Distractions, fatigue, and poor judgment can lead to dangerous situations. Self-driving cars aim to eliminate these risks by staying constantly alert and making data-driven decisions. They do not get tired, emotional, or distracted. However, they are not perfect yet. There are still challenges, especially in unpredictable environments like heavy rain, snow, or complex urban traffic, where human intuition plays a significant role in making safe driving decisions. One major challenge is handling edge cases. These are rare or unusual situations that the car may not have seen before. For example, a person in a costume crossing the road or unexpected construction changes. Humans can quickly adapt using common sense, but AI systems rely on training data. Engineers are working to improve how cars respond to these scenarios by exposing them to more diverse data and simulations. The goal is to make the system robust enough to handle not just normal driving conditions, but also the unpredictable situations that happen in real life every day. Ethical decisions are another complex issue in self-driving technology. In rare situations, a car might have to choose between two harmful outcomes. For example, should it protect passengers at all costs or minimize harm overall? These questions do not have simple answers and are widely debated among experts. Developers are working on guidelines and frameworks to handle such scenarios responsibly. Governments and organizations are also involved in setting regulations to ensure safety and fairness. This shows that self-driving cars are not just a technical challenge, but also a moral and societal one. Despite these challenges, many companies are making rapid progress. Tech giants and car manufacturers are testing autonomous vehicles on real roads around the world. Some cities already have self-driving taxis operating in limited areas. These early deployments help gather valuable data and improve the technology further. As systems become more reliable, we can expect wider adoption in the coming years. The transition may be gradual, but the impact will be huge. Transportation could become safer, more efficient, and accessible to people who cannot drive, such as the elderly or those with disabilities. Self-driving cars could also change how cities are designed. With fewer accidents and optimized traffic flow, roads may become less congested. Parking spaces could be reduced as shared autonomous vehicles become more common. This could free up space for parks, walkways, and other public areas. Additionally, reduced fuel consumption and smoother driving patterns could help lower emissions, making transportation more environmentally friendly. However, this depends on how the technology is implemented and whether it is combined with sustainable energy solutions to truly benefit the planet in the long term. In conclusion, self-driving cars represent a powerful combination of artificial intelligence, advanced sensors, and real-time data processing. They have the potential to transform the way we travel, making roads safer and transportation more convenient. While there are still challenges to overcome, the progress so far is remarkable. The future of driving is not just about controlling a car, it is about letting technology take over the task entirely. Whether you are excited or skeptical, one thing is clear. Self-driving cars are no longer a distant dream. They are becoming a reality faster than most people expected.